This is a practice version of Progress Check 1.1. Question number 1. Insert one of the three symbols, smaller than, greater than, or equal to make the following statements true. So the symbols that we're using are the smaller than, greater than, and equal to. I'll place two numbers so that this makes a bit more sense. So the first sentence is read as 4 is smaller than 6, 6 is greater than 4. How do you remember which one is which? There are different tricks you can use. One of them is that this symbol looks like a crocodile mouth. So the crocodile will want to eat the bigger number. Therefore, it's going to eat 6. And same thing underneath, it's going to eat 6 as well. So it's facing 6. But another way to look at this is that it's pointing at the smaller number. So it always points at the smaller number. And if we compare 27 and 72, 72 is bigger than 27. So the crocodile will want to eat it. So the crocodile mouth is facing 72, but it's pointing at 27, which is the smaller number. Now we've got minus 47 and minus 56, or negative 47 and negative 46, which I'll quickly show using a number line. So if we have a number line here or thermometer, we go 0, 1, 2, 3, 4, 5, 6, and so on. So the numbers will go up. Whereas under 0, we've got the negative numbers, so we go to minus 1, minus 2, minus 3, minus 4, minus 5, or negative 5. Now, although the digits are going up here, we've got 1, 2, 3, 4, and 5. In terms of the value, these numbers go down because we've got minus 1, minus 2, minus 3. So the symbol in front tells us that these numbers are going down. And a temperature of minus 1 degrees is lower than 0 degrees. The temperature of minus 2 is lower than 0 or minus 1, and so on. So looking at the digits here, although 56 is greater than 47, minus 56 will be smaller than minus 47. So we'll need to use this symbol, the greater than symbol, and is read as minus 47 is greater than minus 56. So it's facing the bigger number, but it's pointing at the smaller number. Now we've got 5.2 and 5.20. We're all familiar with this amount, which is £5.20. So it's £5 and 20 pence. And 5.2 looks very similar, but does it mean the same thing? So I'll use the context of money to show that as well. So we'd have 1, 2, 3, 4, 5 whole pounds. And the 0.2, using again the coins, are represented by splitting the coin into 10 equal parts and highlighting 2 of them because it's 2 slices that this represents, 2 out of the 10. And since the coin has a value of 100 pence, if I split it into 10 or divide into 10, that means that each slice will have a value of 10p. So 2 slices will be worth 20 pence. So again, this is the same as the 5.20 we had at the top. So 5.2 is equal to 5.20. When it comes to anything other than money, such as liters, milliliters, centimeters, whatever you're measuring, these two will be equal, and you can show them either way, either as 5.2 or 5.20. Whereas when it comes to money, you must include that 0 because it must tell what is the value of the pennies. So these are the pennies, these are the 10p coins, and these are the pound coins. So I must put an equal sign here. Now looking at 12 times 2, or 2 lots of 12, which is 24, and 4 lots of 6, which is again 24, so they are equal. I must put an equal sign in between them. Question number 2. You must be maximum 1.8 meters tall to ride on a roller coaster at Romy Park. Circle the correct description of this out of the following. So when we say maximum 1.8 meters, it means that you can be 1.8 meters. You can't be any taller, but you could be shorter. So you could be 1.7, for example. You could be 1.6. So we're looking for a symbol that represents that. So it includes 1.8 as well. If you look at the first option, we've got height being smaller than 1.8. So that means it can be 1.7, it can be 1.72, 1.6, it could be 1.5, so anything underneath, but it doesn't include 1.8. So this is not the correct option. Looking at the second one, we've got height being greater than 1.8. So what this means is you can have 1.9, we could have 2, you could have 2.1, you could have 1.92, but it does not include 1.8, and it's greater than. And looking at the question, we said maximum, so that's the highest value that you can take. Looking at the third one, we've got height is equal to 1.8. Now, based on this, it would mean that you'd have 1.8, but you can't have 1.9, you can't have 1.7, you can't have 1.73, 1.93. So this is not the correct option either. It doesn't represent what the question is asking. Looking at the fourth one, we've got a height of greater than or equal to 1.8. So that means it includes 1.8 because it's got this line over here, but it's got to be greater than. So it means 1.81, for example, 1.82, 1.92, and that's not the case according to the question. So this is not right either. Looking at the last option, we've got height being smaller than or equal to 1.8 meters. So it can be equal to 1.8, which is good. It can be smaller than as well. So it can be 1.7, 1.6, can be 1.72, can be 1.68. So that looks like it meets all of the criteria in there. So that's the correct option. Question number 3. Look at this list of numbers: 8, 5, 3, 36, 20, 18. Write the multiple of 9. So multiples, there is a key word there, multiply, that helps you work out multiples. So that means you multiply 9 times 1, and that gives you 9. 9 times 2, 18. 9 times 3, that's 27. 9 times 4, 5, and so on. So these are the multiples of 9. 9, 18, 27, 36, 45, 54, and so on. Which one of these numbers is appearing here? And that's 18. So 18 is a multiple of 9. Write the factor of 30. So factors, to help you remember, there are different factors that contribute to something. For example, to pass in the course, it's got to do with attendance, punctuality, doing homework, and a range of other things. These tend to be smaller than the number itself, so there would be smaller factors that they all contribute to the big thing, which is passing the course, and in this case that's the number 30. But it can also be a case of one factor determining the whole thing. So a factor can be as big as 30, and I'll give you an example. the factor of turning up to an exam can decide whether you pass the course or not, for example. So that can happen as well. So looking at factors, we'd have 1 and 30. So 1 and 30, because 1 times 30 makes 30. So both of these are factors of 30. Then 2 times 15 makes 30. 3 times 10 makes 30 as well. 4 is not. 5 times 6 also is 30. So all of these are factors of 30. Which one of these is appearing in the list? And we've got 3. So I'll write 3 down. Write the square number. So square numbers, as the name suggests, they make squares. So if I have 1, got to look a bit more like a square. So they equal, the sides are equal. So if this is 2 centimeters and this is 2 centimeters, the area of the square will be 4. So 4 is a square number. If I have 3 meters or 3 centimeters times 3, that's going to be 9. So 9 is another square number. So 4 times 4, that will be 16. 5 times 5 is 25. 6 times 6 is 36. And as you can see, 36 is appearing here. So I'll write 36. Prime numbers. As we've said before, prime numbers are the numbers that can be divided by 1 and themselves and have whole numbers as answer. So that's the first one is 2, because 2 times 1 is 2, 1 times 2 is 2. Or using division, 2 divided by 2 equals 1, and 2 divided by 1 equals 2. So it's just 1 and the number itself. The next one is 3, then we have 5, 7, 11, 13, and so on. Which one is appearing here? And we've got 5. The thing to remember with prime numbers is that 1 is not a prime number. Question number 4. Given that 42 times 36 is equal to 1512, what is 0.42 times 3.6? As you can see, the digits remain the same. It's just the decimal point. So to help us with this, I'll go through an example with some easier numbers to work with so that we can see what happens when you change one of the two factors, what happens to the total or the product. So if I take 4 times 6, that is equal to 24. 40 times 6 will be equal to 240 because you go 4 times 6, 24, and add the 0. 40 times 60 will be 2,400 because you just multiply 4 and 6 and you add the other 2 zeros when you multiply. Now, what happens when you get 0.4 times 6? That is 2.4. So if I compare it to this one at the top, 4 times 6, all that's changed is that we've got 0.4 instead of 4. So how can I do that? What do I do to 4 to make it 0.4? And what I'm doing is dividing it by 10. But I'm keeping the rest unchanged. So to the answer, which was 24, I'm just going to divide that by 10. So 24 divided by 10 gives me 2.4. Now, if I have 0.4 times 0.6, So what I've done to the 4 is I've divided it by 10, and to the 6 I've divided by 10. So twice this has been divided by 10. So to the answer, which was 24, I'll divide twice by 10. So I'll go initially the decimal point was there, so 1, 2 places, so the decimal point will be here now. So 0.24 is the answer. So going to these numbers, what's happened to 42 to become 0.42 is that it has been divided by 100. So we have a division by 100. So to 1512, which was the initial answer, I'm going to divide that by 100 first. So the decimal point from here is going to move 2 places to go to 15.12 between 5 and 1. Now what's happened to the 36? It has been divided by 10 because it's moved, decimal points moved just 1 place. So I will now go to the answer and divide it by 10. So 15.2 divided by 10 gives us 1.512. So overall, since we divided one of the factors by 100 and the other factor by 10, we have divided the answer by 1000, so which is a collection of these zeros, 2 in the first one and 1 in the other one. So from 1512, we've gone 1, 2, 3 places to make the final answer 1.512. Looking at question number 5, use the symbols such as brackets, addition, subtraction, multiplication, and division to make the following calculation correct. You don't have to use all of the symbols. So we've got 6, 4, and 2, and the answer is 20. By looking at the numbers, aiming to get 20, I can see there is a 6 and a 4, which makes 10 if I added them, and there is 2, so 2 lots of 10 will make 20. So I'll add these 2 and I'll put them in brackets and multiply by 2. The reason why I put them in brackets is that if I left them without brackets, 4 times 2 would come first, which makes 8, and then we'll have to add 6 on top, which doesn't total 20. Question number 6. Answer the following calculations. We've got -8, add 3, and I'll use a number line to help me with this. So we've got 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, and so on. And above 0 we go 1, 2, 3, 4, 5, and so on. So what's the initial temperature if we consider this number line to be a thermometer? So that would be -8. So we are right here at the moment. And then we add 3, so that means the temperature will go up. So we go 1, 2, 3 degrees up. And we landing on -5. So the answer is -5. Then we have -10 minus -5. So what the initial temperature is -10. So we're starting on -10. But what do we do then? Since we have 2 signs next to each other, I'll circle them. and make a smiley face. If the two signs are the same, then they turn into positive. So this turns into minus 10 plus 5. So those two signs, just those two, will turn into positive, not the overall result. So we go to minus 10 and then add 5. So 1, 2, 3, 4, 5. So again, it lands on minus 5. And you're wondering now, what if it had minus 10 plus 5? Again, because the two signs are the same, they will turn into positive. So there is a smiley face represented. Minus 10 plus 5, that is the same as the one above, so that gives us minus 5. If you had minus 10 plus minus 5, these two signs next to each other, they're different, so the outcome of them two is negative, so this becomes minus 10 minus 5, which is minus 15. Because from minus 10 you drop it another 5 degrees, you're going down another 5. Then minus 10 minus plus 5 would give us the same result as this last one, meaning that you'd be negative because the two signs are different. So we'd have minus 10 minus 5, which totals minus 15 again. So one way to remember, when you're adding and subtracting positive and negative numbers, the two signs, they are right next to each other. If they are the same, then they turn into positive. If they are different, they turn into negative. I drew these faces because I'm trying to link it with when you've got both of your eyes closed, like in this first example, then you are asleep and you are content, you're happy. When you've got both of your eyes open, you're fully awake and you're happy as well. But if you've got one eye open and one closed, you're trying to sleep, but maybe some noise is not letting you sleep, then you're unhappy. So those two signs turn into negative. And the same thing with this last one. The same rule will apply when it comes to multiplying and dividing. But the only difference is that when multiplying and dividing, you don't have the signs next to each other. So looking at this one, for example, we've got minus 7 times minus 8. So a minus and a minus, they both negative, so both the same. That means the answer will have a plus. 7 times 8 is 56, so the answer is just 56. You don't need to have a positive sign in front, but it does not matter if you do. And same thing in the last example when you've got minus 36 divided by 6. So that 6 has no sign in front at the moment, but if it doesn't, you can assume it's a positive one. So we've got a negative and a positive, which means they are different, so the outcome will be negative. So minus 36 divided by 6 is going to be minus 6, because 36 divided by 6 is 6. Now this links to adding and subtracting positive and negative numbers, as you saw. So the same rule that I explained through the faces, but that's going to be only valid for the signs next to each other. You can't, for example, look at this. So let's say we've got minus 3 plus 8, and look at them and say, oh, it's a negative sign and a positive sign, so the answer is going to be negative. No, that's not right, because if we look at this now, take the initial temperature, minus 3. So if you go to minus 3, and if you add 8, you're going to go 1, 2, 3, 4, 5, 6, 7, 8. It's going to go to 5 degrees. So the answer will be plus 5, not negative 5. So that is the difference between them two. Looking at adding and subtracting, it's just the signs next to each other that you consider. Otherwise, you use a number line to have the starting point and then either add or subtract, whatever you're doing. When you have two signs next to each other, look at them. Are they the same? Are they different? Then just rewrite that, just like I did here. I did minus 10, add 5. So I rewrote that second one. Now I can decide, starting with minus 10, adding 5 on top, and that goes to minus 5. Question number 7. Write the missing value below to make the calculation correct. So we've got 15.2 times the number equals 15,200. So what's happened? We've got the same digits, 1, 5 and 2. We just have more zeros and the decimal point has shifted. So I'll write the answer underneath. So from this place here, the decimal point has gone to the right 1, 2, 3 places. So 1, 2, 3 zeros. So 15.2 is multiplied by 1,000 to give us 15,200. 2.83 has turned into 283. So the decimal point has shifted 1, 2 places to the right. That means we're multiplying by 100 because 100 has 2 zeros, just like the 2 places that the decimal point has shifted. Question number 8. Circle the correct answer. 0.67 is the same as which one of these? So this links to scientific notation. 6.7 times 10 to the power of minus 2. We've got 6.7. When you multiply by 10 to negative power, that means you're moving in the negative direction. Think of the number line, you're moving in the negative direction. So, and this tells us how many places, and that's 2 in the negative direction. So with decimal point, we'll move 1 and then 2. So it's going to go here. So we fill this gap with a 0 and we put a 0 in front. So this becomes 0.067, and that doesn't match what we have in the question. So this is not the right option. Now looking at the second one, we could try and solve this, but just looking at the first number, it's 0.67, and in scientific notation, you need to have a number which is equal to or greater than 1 and smaller than 10. This is actually smaller than 1, so it's not right for scientific notation. So this is not a correct answer. Looking at the third one, we've got 6.7 times 10 to the power of minus 1. So 6.7, that's a good decimal in there. We're moving in the negative direction because of this sign, and it's one place. The power tells us that. So we go in one place. So that means we've got 0.67, and that matches what we have in the question. So this must be the correct one. Let's have a look at the last option. So we've got 6.7 times 10 to the power of 1. So 6.7, when you multiply to the power of 1 and 1 has a positive sign in front, it's positive, so we're moving in the positive direction. So that means just 10. So we move in one place. So this becomes 67, and that doesn't match what we have in the question. So option number 3 was the right one. Question number 9. Write 75 as a product of prime factors. Prime factors are factors of the number which are prime. So we'll write some prime numbers to help us. We've got 2, 3, 5, 7, 11, 13, and so on. So I'll write 75 to begin with, and I'll find two factors of 75, or two numbers that would multiply to give us 75. So trying to fit any of these by 2, I can't divide to get a whole number. I could divide by 3. So if I divide this by 3, which is a prime number, and I'll circle the prime number to help me remember. So how many 3s would fit into 7? That would be 2 of them, and there is 1 remaining. Into 15, that would be 5. So 3 lots of 25 gives us 75. Now I won't circle 25 because it's not a prime number. 25 can be written as 5 times 5, and a prime number. So 5 is a prime number. So I'll circle them both. So 75 is equal to 3 times 5 times 5. So that is 2 5s in there, and I've circled them all. An extension of this is to write 75 as equal to 3 times 5 squared, because we've got 2 5s. And this is called the index form. Question number 10. Given that A, which is a number, but we're not given it, equals 2 cubed times 3 cubed times 5 squared, and B, another number, is equal to 2 cubed times 3 times 5, calculate the highest common factor of A and B, the two numbers. There is a hint: use Venn diagram to help. So we'll use the Venn diagram. So the number which is A, and we don't know what it is, and we've got the other number B. So we'll try and place all of these prime factors within these circles. So all the prime factors of A, and then prime factors of B, and in this area will go the ones that overlap, the ones that are in common for both. So I can, since this is written in the index form, I can write this as 2 times 2 times 2, because there are 3 of them, times 3 times 3 times 3, times 5 times 5. And I can rewrite B as 2 times 2 times 2 times 3 times 5. It means the same thing. So let's place the ones that go in the middle, the ones that overlap. So we've got a 2 here and a 2 for B, so I'll place a 2 in the middle. Just one of them, because by placing it in the middle, it means it is for both. And then there is another 2, and there is another 2. Then there is a 3, and there is a 5. Now, whatever is left, I've got 3, 3, and 5 here, and I haven't got anything left for B. So the highest common factor is found by multiplying all of the numbers that overlap, all of these prime factors that are in common for both of the numbers. So that would be 2 times 2 times 2 times 3 times 5. So multiplying these out, we'd have 2 times 5 makes 10, 10 times 3 makes 30, 30 times 2 makes 60, and 60 times 2 makes 120. But you could have done 2 times 2 times 2 times 3 times 5 in any order. It does not make any difference. Without the Venn diagram, you could have done this also. So just having these numbers in there and looking at the ones that overlap. So as I cross them out, if there was a 2 in there, I'll just write 2 in here. There is a 2 in there, and cross out, I'd write 2. A third 2, so times 2. There is a 3 that overlaps, 3, and then a 5 as well. So that gives us 120. Question number 11. Given that A is equal to 2 cubed times 3 cubed times 5 squared, and B, another number, is equal to 2 cubed times 3 times 5, calculate the lowest common multiple of A and B. Hint, use Venn diagram to help. So we'll use the Venn diagram. So we've got A and B. Let's place in the middle first the ones that would go there. So the ones that overlap, got 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5, and B is written as 2 times 2 times 2 times 3 times 5. So 2 we have in common, put 2 in there, and another 2, and a third 2, 3, and 5. And the rest of them for A would go here, so 3, 3, 5, and there is nothing left for B. We work out the lowest common multiple by multiplying all of the numbers. So we would go 3 times 3 times 5 times 2 times 2 times 2 times 3 times 5. Now, since you're not going to use a calculator for this, I suggest that you pair up the numbers to make easy numbers to work with. So I'll pair up the 2 and the 5 and the 2 and the 5 here. So this makes 10 and another 10. So we'll go that way. So 10 times 10 makes 100. So we've done these. Then we can do times 3, so that makes it 300. 300 times 3 makes 900. Times 3, 2,700. And finally we have a 2, so 5,400. So trying to make tens is a trick, then eliminating the bigger numbers, so multiplying first by the bigger numbers, because that would be easier than multiplying big with big numbers. So that gives us 5,400, but we could have done the same thing without the Venn diagram. So having the numbers written down, so we'd have, although it's given in index form, we could write it as 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5. So that would be A, and B written as 2 times 2 times 2 times 3 times 5. Looking at the numbers in common, just rewriting them here and multiplying them out. Now, could it be confusing how you work out lowest common multiple, which numbers you multiply for the lowest common multiple, and which numbers you multiply for the highest common factor, which is what we looked at previously. Factors, as we've said before, tend to be smaller than the numbers themselves. So for that reason, we're multiplying fewer numbers, so only the numbers that overlap in here. That's when we've got the factors, so highest common factor. Whereas lowest common multiple, and as we said, multiples tend to be bigger than the number itself. So we're looking at all the numbers, everything within the Venn diagram to get the lowest common multiple.